All right, folks, welcome to week 2. I'm just going to do a quick introduction as to what you guys should accomplish throughout the week. Just like normal, go through the announcement. I won't read through this now, obviously you can do that, but I'll kind of just verbally go through what the announcement says. You'll see there's a few things, 4 modules that I'd like you to get through aside the announcements today. The first one is a flow chart for the scientific method. There's a video on the scientific method, and there's a quiz on the scientific method. So as you could guess, this week we're kind of focused on the whole process of science. So how do you propose a question or look at something to investigate, do a little research, make hypothesis, collect data, doing experimentation and then forming conclusions, and then maybe repeating that process as needed. So that's kind of the primary focus of the week. I may add a couple of links as the week goes on. But everything that you have to do, everything that's going to be graded, basically the 2 things that will be graded will be the paper airplane mini lab at the end and then the scientific method quiz. So anything else I add throughout the week is just going to be kind of supplemental. So please remember, anytime you guys can always feel free to research above and beyond. I kind of encourage you to do that also, take an interest, a little bit of independent study into, the area that we're focused on, okay? So I will open up the flow chart here for starters. In the flow chart, what this is doing is just giving you kind of a visual representation of what the scientific method is. So I'll review some of that very quickly. I kind of talked about it a bit. But the scientific method, the whole idea of most experimentation or science processes or disciplines in science and so forth, if you were a chemist or biologist or a physicist, they're normally set out to answer questions or answer questions again and again, or with slight changes in variables and variations. So you're always questioning the unknown and trying to see, is this true, is this false? Trying to be creative thinkers, trying to explain ideas or ways that things do work, or maybe why things don't work. It all starts with the question: what are we going to try to figure out? Then what you try to do is define some sort of background and research. Oftentimes when you have questions, other people have maybe already answered the question or tried to answer the question. Your job is to see what's out there and then base a hypothesis, which is a guess or your prediction on what you think is going to happen when you attempt to do whatever it is that you're doing or try to answer the question that you're going to answer. Then, after you've made a prediction, you are actually going to test your hypothesis. You're going to say, all right, I believe that the ocean's blue because of this. Like whatever it is that you're going to be doing, you're going to actually try it out. Now this week, what you're going to focus on when you propose a question, do research, make a hypothesis, and test, you guys are going to be looking at various designs of paper airplanes. So the idea of the paper airplane isn't that you're going to learn a ton about aerodynamics or how airplanes fly, but it's more the proposing a question and doing some research on different airplane designs, making a guess or a hypothesis, actually testing it with a hypothesis, and then analyzing your data. So after you've thrown your airplanes and you measure maybe how far they go or how long they fly in the air, then you can go back and you can report, hey, what paper airplane design did go the furthest or did sustain flight the longest. So the flow chart, all the different colors, is kind of more specific. On the right hand side, observation, hypothesis, experimentation, data analysis, and conclusion. Those are kind of all the steps of the scientific method. So review that. You can use that as your own data. And then if you guys want, there is also a video. And I won't play the video right now, but if you open the video, this is on the scientific method. So they do it's a short video, it's not a very long video, so please watch it. This talks a little bit about how you guys actually would conduct an experiment, how you would gather data and share your ideas and so forth. So just a quick experiment, and then there's a really quick quiz. It's just, scroll down, there's a real quick quiz on the scientific method. It's only 6 points, so not a lot of questions on there. And then the paper airplane mini lab. So I'll open this. This will probably take you longer than the rest of the assignments combined. So let's see here. I'll open this one up. It's going to ask you to make a copy. So if you make a copy, You will have your own Google document. And again, just like last week, you guys are going to want to answer most of your questions, propose most of your questions and so forth right on, right on this document. So let me zoom in just a little bit here. Let's see. There we go. So the objective is for you guys to research various airplane designs. So you see that I broke it up into 4 phases. So the first one is to do some research. The question anyways, the proposed question is, what paper airplane design is going to help you sustain the greatest flight distance, and then the other one is which paper airplane design is going to sustain the greatest flight time. So that's your question. Then you're going to do research. So following through the process, you're going to do some research and finding a design. So this is where I will add some links. I have a PDF that I'll upload that just shows various paper airplane designs, like folding patterns that you can do, or you can look up your own. You're gonna pick whatever 2 designs you think will best answer the question for greatest distance and greatest flight time. So you're gonna want to build and test 2 different types of airplanes. Building process, I just encourage you to have fun with it. You don't need much for material. All you need is a single sheet of paper. You can use more than one in your trials, but the actual plane itself should only be made out of 1 piece of paper. And for counterweights or counterbalances, you guys can use up to 3 paper clips. Okay. Phase 3, you're going to have sketches and designs, and you guys are going to be finding the center of mass of some of these planes. So phase 3, I ask you to put a sketch or a photo of your distance plane and a sketch or a photo of your extended flight plane. And you'll notice in here, if you read the directions, it says to include scale dimensions in the diagram, draw a solid dot on the diagram and label it as your initial center of mass. So I'll demonstrate for you here very quickly what the center of mass looks like. So how you're going to balance your airplane. This is how you're going to find your initial center of mass. Once you've designed a paper airplane, this is just a simple design, you're going to flip it upside down, and you're going to just try to balance it on your fingertip somewhere between the nose and the tail of the plane. So it takes a little bit of balance, and they kind of want to fall off pretty easily. But once you get it to a point where it kind of balances, like somewhere in there, wherever your fingers are resting, you're going to want to, pick the plane up from there, and you're going to want to put a dot either right on the airplane. So on this one, I don't know if you can see, but I put a red dot here and labeled it as the CM or ICM, which is your initial center of mass. Now, if you're going to upload a photo of your airplane, when you make the airplane, take a picture of it, you can upload it and paste it right into the document. Again, a distance plane and an extended flight plane. Once you guys have a plane, you guys are going to do a little bit of testing and modifying of your airplane. So you're going to do some practice throws. You can go outside if you'd like to, maybe a larger place in the house, a hallway, an apartment building, and whatever. Just try not to throw them at people potentially. But you're going to do some tests and modifications. So this is even before you really collect any official data. You're just going to see how far you can get the plane to fly and how long you can get it to fly. If your plane is consistently doing something like nosediving or turning to the right or like flipping over, you can use the paper clips to add weight to the front or the back of the plane. You can change the angle of the fins to get the plane to go different directions. Remember, whatever you do to the fin, for example, if I raise the left fin, it's going to push the left side of the plane down, or if I lower the left fin, it's going to push the left side of the plane up, and vice versa on the right. So if you want the plane to roll left or right, you can make adjustments to the fin. If you put both fins up, put them both up, it's going to want to make the plane go up. It pushes the back of the plane down. Or if you put both of the fins down, it should lift the tail of the plane or make the front of the plane go down. So those are all things for you to test. Then you're going to do some analysis prior to collecting your official data, answering these 5 questions: why you chose the design, which one's going to accomplish the longest flight, what materials would have made it easier, and then for question 4 and 5, this is kind of like your hypothesis. You're making a prediction on how far your plane is going to travel or how long your plane is going to be in the air. Then you're actually going to test these. So you'll see horizontal distance, flight 1, 2, and 3, hang time for flight 1, 2, and 3. getting time for your airplane shouldn't be too bad. If you have a cell phone or even if you access to the internet, which you must, you guys can get a stopwatch online, and all you're going to do is ready, set, go, toss your plane and time how long it takes before it hits the ground. That one isn't too difficult, but sometimes people are wondering, what to do for the distance, like how do I measure distance? Well, you have a few options. If you were in the classroom, I would say we'll measure distance in meters and use a meter stick. Now you might not have a meter stick at home. You maybe don't even have a tape measure at home. I don't care what units you measure your distance in, but you need to find some sort of a standard unit to use. So for example, if you have a tape measure at home, you can definitely just measure the distance in feet, and you can tell me in feet how far it went. If you have a meter stick, awesome, use a meter stick. If you don't even have any of those, what you can do is you can use a pace. So your pace is basically, how many steps, how many of your normal steps you walk to get to wherever you're going. So maybe you can define, a starting point, lay something down on the floor, or if you're outside, make a mark on the grass or in the dirt or something. And always put your toes there when you throw your plane. And wherever your plane lands, maybe just count how many steps it takes to get to your plane. Any of those are fine. I'm not telling you what units you have to use, because again, as long as you're measuring in the same units, we're just trying to see which plane went the furthest. So if you just count paces, that's perfectly fine. So if you have questions, you can email me, but be creative with that. Don't feel like it has to be in feet or inches or meters. You could do paces if you want, so that's completely up to you. Once you've gotten done with all the flights, you're going to answer the analysis questions, which is just basically answering the hypothesis, how far did your plane go, which one had the greatest hang time, and so forth. So that's going to be mostly it for this week. Again, I'll add some other supplemental material as the week goes on, but this should all be ready for you guys this week. So appreciate it. Have a good week. If you guys got questions, please email me or call. Take a look at the syllabus. All of the information is there. Thanks.